distribution. In a design thinking approach, we have taken one topic which is related to the electric field, how the charge distribution will be takes place in the electric field. We know the charges which is nothing but it is related with the help of electrons. And in electrostatics, the charges which is closely related to the force and plays a vital role in electromagnetic field. And relating the charges, the electrons and charges, the force will be acting on the charges. And with the help of charges and forces in electromagnetic field, it is related with the help of Coulomb's law. And when we are having charges, there will be a like charges as well as unlike charges will be there. We know already the like charges will be attract each other and unlike charges will repel each others. Keeping this principle, we can directly derive the Coulomb's law. With the help of this Coulomb's law, we can derive the forces acting on two charges. And keeping the forces, the electric field also be acting on our charges. And coming to the charge distribution, in particular the charge distribution will be takes place in line. For example, in infinite sheets also there will be a charges. In also the volume there will be a charges. And in day-to-day real-time example also, the charges as well as the electric field will be present in our all the objects what we are using. So, the electric field will play a vital role in our day-to-day life also. Keeping this the electric field distribution in charges, taking the design thinking approach, we know that it is having 5 stages. First one, the empathy part, define part, ideate and prototype and test part will be there. In each topic you can discuss this electric field distribution in detail. It have the discussion for a few more minutes.
I am going to explain the empathy part. We all in our everyday life, we already know the object. We have already seen many things that without touching the objects. When we rub the hair in the balloon, when it sticks to the wall, some paper pieces, some small paper pieces, when it attracted to the charged objects. Even though when sometimes we are pulling the carpet, it leads to some shock due to the metal objects. These all are not visible to us, but the charges, the forces acting on it, but we cannot see in our naked. We understand force only when there is a physical contact, like pushing or pulling. But in electrostatics, we need to understand that charges act beyond our naked eye without the physical contact. That's the problem. The students cannot understand the concept of electrostatics, but they are just remembering the formula without understanding the concept. They need a clear vision of that force, even though it can affect the space around them. Even though when there is no physical contact or object is nearby it, the charges we cannot see the charges with our naked eye, but there is a act beyond the charges, but we cannot visually see them. But there is an effect when we get the charges with the object nearby or without the object, they will act around them. They took their own space and act around it. This tends to understand as electric field is everywhere around us, but they might be have the physical contact, or they do not have the physical contact around them. In this way, we can understand the electric field due to charges.
I am going to see and define part about an electric field. As Kavya said, we know that electric field can act with or without any this. So we can have an example. You know that all we use and comb day to day life. When we take the comb and comb the hair, we have a little bit of that oil. When we take the paper and keep that near, we can experience some force around it. We all did this in one time in a life. So it is an examples of an electric field at everywhere. So we at this what I am conveying is when an electric field is kept at a space, it can act with or without any force. When another charge come into the space, the two charge will not touch each other, but we can experience the force. So it can be defined by an electric field. So electric field is defined by when an electric field is defined as the charge around an electric field which is exert to one force at another charge. So we also know that the Coulomb charge also has in two charges which is proportional to the product of charges and inversely proportional to the distance between them. We can also say that charge can be electric charges can be surround everywhere in the electric field.
Explain the ideal part. Electric field can be visualized by using the electric field lines. These lines shows the direction of force on a positive charge, and the density of the electric field indicates the surface of the electric field. And the light charges produces a repulsive field, and the unlight charges produces an attractive field. And the uniform field have parallel lines, and the non-uniform field have curved lines.
See about the prototype. In the prototype, we can see about this electric field cannot be seen in real world, like in a naked base, as said Kavya. So we can how we can feel that electric fields are in this. So we can obtain through the experiments or through the models. Like the electric fields are using the experiments like papers. We can get some charge particle near the paper will attract it. This shows that the field is present near it. When the positive charge and negative charge are repels and as well as attracts each other. When they are combining in the electric field lines. So in real world application, it is used in capacitors and in all the electronic devices. So electric field lines are observed through the diagram by positive and negative charges. If there is more than one charges, we can use the super principle theorems. Like Coulomb's law states that the combinations of the two charges is directly proportional and the square of the distance is inversely proportional to it.
Field is a region around the closed path which is used to explain the electromagnetic, and it takes a small positive charge in the field, and it combines theoretical part into experimental part to confirm the result. And the electric force explains the presence of the electric field, and it converts small positive charge in the field, and it explains the presence of the electromagnetism.
Now from our discussion, we came to know that how the electric field is distributed in the charges, and we have explained the Coulomb's are related to the force and charges, and electric field also related with the help of charges. Okay, thank you students for